All right, Kaylee, you are at the state volleyball tournament. Say hi to my alma mater. Mayor Lutheran going for its third state title in a row, but class put me down the other day because I went to a small school, so I'll just see how that works out. Corn is being emptied onto a pile at a rate of 12 cubic feet per minute. It's taking the shape of a cone. How fast is the height of the pile increasing when the pile is 6 feet high, has a base diameter of 8 feet? So this is an excellent question. We got Farmer Grant over here. He's trying to get some corn feed to his chickens. No, he doesn't feed them corn. That would just be bad because then they got all that. Or wait a minute, do you feed your? You do. You do feed them corn. See, somebody was telling me that feeding corn isn't good for your animals. Okay. But starch is turned to sugar, and then sugar is bad, and it breaks down your liver, and you die. Okay. Guess it depends on who you ask. Got a cone. It's a pile. What do you want? Then you have to change the problem, but I'm trusting you're intelligent enough to know how to do that, so we won't cover that part. Okay, what's changing? You tell me everything is changing. Height, time, volume, diameter. Everything's changing, isn't it? There's nothing that's really remaining constant in this problem at all, is there? Yeah. What? Corn. We are continuing to pour corn. That is remaining constant. Very good. We're not going to switch to Cheerios or something else. Frosted Flakes. No Frosted Flakes for the chickens. Okay. So I need a formula. What is the formula for the volume of a cone? One-third pi r squared h. So no, he's absolutely right. One-third times the area of the base. The area of base is a circle, so pi r squared, right? So it's really one-third of the height times the area of the base. Got it? Uh-oh, I got two variables. Does it remain constant? Does the radius change? Yes. Does the height change? So we can't plug in either one. So what rule would we have to use? We would have to use the product rule. Let's think about this for a second before we do something so extreme. What do we actually know? We know that V prime is 12. How fast is the height of the pile increasing? So what are we trying to find? H prime. Do we know the current height? Has a base diameter of 8, so we know the current radius is 4. Now, this is where you have to think ahead. If I take the derivative of this and use the product rule, will I come up with an H prime at some point? Will I come up with a V prime at some point? Will I come up with an R prime at some point? Do you know R prime? No. So if we use the product rule, we're going to come up with two unknowns, and that stinks. We got no shot. I like the way you think, but it's not correct. Because it's changing. So what I'm going to do is I'm going to look at the height and the radius and understand that as the height increases, the radius is going to increase at a very specific rate that's proportional. For example, if I drew another cone right on top of this, okay, wouldn't you say that the triangles made up by the center, that those would be similar triangles? And if triangles are similar, then we know that their sides are proportional, right? So what I have is the height over the radius is equal to something. What is the current height? 6. What is the current radius? 4. So does everybody agree that the height over the radius is equal to 3 over 2? So in other words, height is equal to 3 over 2 times r. Multiply the r to the other side. So I'm going to take that and plug it in right there. Yes, you could have solved for r instead of done h. Oh, we want h, don't we? Because we want to come up with h prime. We don't want r. Let's undo that. Good job, Grace. Okay, so let's scratch that. Go backwards. Oh, hey, stop! Don't! Come back. Okay, so I'll cross multiply. 2h is equal to 3r. Awesome. I've got 2h is equal to 3r. Do I want r equals or do I want h equals? I want r equals because I'm trying to solve for h prime. So I divide both sides by 3. So I get r is equal to 2/3 h. So I'm going to use a little bit of this box here. Now that I've done my magic, I've got the volume is equal to 1/3 times pi times 2 over 3h squared times h. Now, don't take the derivative right now. You would have to use a chain rule. Let's multiply this out. Volume is equal to 1/3 pi. What's 2/3 squared? 4/9 times h squared times h. Or volume is equal, whoop, don't do that. Or volume is equal to 1/3 times 4/9 is, so 4 pi over 27 times h to the third. Okay, cool. Can I take the derivative of that with respect to time? Let's do it. Derivative with respect to time of v equals 4 pi over 27 h cubed is equal to, what do I get? V prime, 12 pi over 27. 12 pi over 27. I won't simplify it because you guys didn't. We'll just leave it. H squared, H prime. Do we know the current volume? Or do we know the rate of change of volume? 12. It's 12 pi over 27 times 6 squared, which is 36 times H prime. There we go. 12 divided by 12 divided by pi divided by 36 times 27.238. H prime equals 0.238 what? Feet per minute. Yep. Yep. That was a tough one, huh? That was challenging, wasn't it? In fact, if we don't do another one similar to it, it's just going to leave your brain and you're not going to know what the heck's going on. So let's try another one similar. Bye, Riley. Nice of you to join us today. You should join Knowledge Bowl because you're really smart. You did? Good boy. I do have influence over people. job. 1,000,000 points. It's so unrealistic. Don't let her put you down. Don't keep your day. Even in the midst of hate, keep your day. All right. An inverted conical tank is being filled with water at a rate of 10 cubic feet per minute. Oh my gosh, an inverted conical tank. What the heck is that? It's a cone that's upside down. Yeah, it's like an ice cream cone. Very good. We're filling it with water. At a rate of 10 cubic feet per minute. The tank measures 24, has a diameter of 20. At what rate is the height of the water increasing when the diameter of the water is 12 feet? First of all, give me a formula. Good. You got to think very, very closely to what I'm asking you. Is the volume of the cone changing? Is the volume of the water changing? Does the height of the cone change? Does the height of the water change? Does the radius of the cone change? Does the radius of the water change? So just she's a contrarian. Gonna disagree just because. So anyway, you could see exactly what's going on here. That we can't pay too much attention to the 20 over 24, 20 to 24, can we? We got to focus on kind of the 12 and the height here of the water. This is really the focus right here. So as I write these things, what is V prime? V prime is 10. Okay. When I say H, do we know the height? Do we know the height? We don't know the height of the water, do we? That's what we're thinking about, is the height of the water. We don't know the height of the water. What are we trying to find? Trying to find H prime. Okay. We know the current diameter, so what's the current radius? 6, not 10, because we're wondering about, again, we're wondering about the water. Well, you can see that if you were to take this derivative, you would have to use what? Product rule, but I would come up with an H prime and an R prime. We have no idea what R prime is, so therefore we have to get rid of one of the variables. So I'm going to set up a proportion that will get rid of some of it. I'm going to set up R over H is equal to somebody. (10/24). Now I can use the 10/24 in that situation because the water is going to maintain the shape of the cone, right? So that's going to give me the appropriate proportion, but I don't plug in 10/24 as the actual current height. Do you see a difference? So I have 10H is equal to 24R. Do I want R equals or do I want H equals? So I've got divide by 24, divide by 24. I've got R is equal to 5/12 times H. What do I do with that? So volume equals 1/3 pi. What is 5/12 squared? 25/144. H squared H. So volume is equal to 3 times 144. So 512. Oh, it is. Okay. Good job. 25 pi over 432 times H cubed. Can I take the derivative with respect to time? Derivative with respect to time is equal to v prime, which equals h squared h prime. Dump the 3 in front. Three over 1. Top by 3, bottom by 1. Good question. Okay, now, what is v prime? 10 equals 75 pi over 432 times something squared times h prime. Do we know the current height? Shoot. It's right here, isn't it? The radius is 5 over 12 times h. So we plug in 6 for r. 6 equals 5 over 12h. How do we get rid of 5 over 12? 12 over 5, and you get 72 over 5. Good. Are you okay with this? Okay, so we know the current radius is 5, or 6. Duh. Current radius is 6. I'm going to take 6 and plug it in for the radius. That'll allow me to solve for the height. You could have. If we had anticipated that we needed the h, we could have done it right away. And when we multiply then both sides by 12 over 5, we get 72 over 5. We good? Okay, so sometimes in this situation, I just multiply to get some crazy number. 75 times pi divided by 432 times 72 divided by 5 quantity squared. So it looks like I get 113.097 that sits in front of that h prime. So 10 equals 113.097. That's what sits in front of h prime. Now what? Divided by 10, right? So 10 divided by the answer, and I get 0.088. 0.088 what? Feet per minute. Ain't it in there? Good. You have your last one. Flip it over. Last one. Good job. You guys are doing great. This is a full sheet of paper only because I would say, you guys, the last problem we just did, in my estimation, is the hardest problem. This is definitely not as difficult. This is just fun. Yep, you guys will have to wait. You look like a dandelion. All right, so we got a street light mounted on top of a 20-foot tall pole. Do people like listen to this and say, "Oh my gosh, we need to report the teacher," like he's criticizing his students? YouTube, just to be clear, Braden just called me fat, and then I said he looks like a dandelion. So I think mine is a lot nicer than what he said. So this is we're just a little edgy today on Friday, aren't we? Yeah, a little chippy. Yeah, kind of like the Carolina Panthers after last night's disaster. Oh, yeah. All right. Streetlights mounted on top 20-foot tall pole. A man 5 feet tall walks away from the pole with a speed of 4 feet per second along a straight path. He's got a long neck and no torso. Okay, that's how we draw it. He's 5 feet tall. He walks away with a speed of 4 feet per second. Along a straight path. How fast is the tip of his shadow moving when he's 30 feet from the pole? Great point. Who cares? Really, I agree. Um, th- this would be one of the more recent related rate type problems I've seen on the AP exam. So this is a good one to go over. And this is really a classic. Like I want you guys to know, like when I study the problems, like I choose which ones we're going to cover. We're covering all the ones really that I've seen on the AP exam. There's slight twist to a couple of them, but overall does a really good job. And two, just from other courses I've seen people teach, what kind of problems are you choosing to do? Here's where we're at. So a little bit different here. Anybody see this setup? Try to prepare you last year for it. Yeah, good. You actually got two triangles going on, don't you? Are those triangles similar? Why are they similar? They share an angle. That's not enough. You need two angles. Well, they don't share two angles. They don't have a side that's the same at all. This one's incredibly smaller than the other one. Y angle. What's the other angle? 90 degrees. Very good. 90 and 90, and then they have this shared one. If two angles are the same, then the third angle is the same. If all the angles are the same, then they're similar. If they're similar, then the sides are proportional. Awesome. Let's set up a proportion. I got the height over the shadow. Let's think about what's changing. Let's get some variables in here, folks. Is the height of the lamppost changing? Is the height of the man changing? Is the distance the man is from the light pole changing? Yeah, that's a variable. So I got to consider that. D. Sorry. Okay, so that distance is changing. Is the length of his shadow changing? Yeah. So we have D prime, we have S prime as well then, don't we? So we got those four things. Do we know the current distance? 30. Do we know the current D prime? Yeah, he's moving at 4 feet per second. The question is, at what speed is his shadow moving? Okay, so we don't know that, and we don't have the current length of the shadow. Could we figure out the current length of the shadow? We could. Let's wait to see if we even need it. Okay, we might not need it. Okay, so somebody give me a proportion. Okay, so you're going height over height, which is fine. You could do that. I'm going to choose to set up height over shadow. So or height over. I'm sorry, or height over. Yeah, because they both have shadows. So we're going to go height over shadow. So I'm going to go height is 20 over. So 20 over this entire length. Distance plus S. This is his distance from the light post, and this is his length of his shadow. Both are changing, so I have to use a variable for both. Do you see that? That's your key. If they are changing, you have to use the variable. We said the height wasn't, so therefore you don't have to use a variable for the height. What is his height? 5. What is that length? S. Let's cross multiply. S is the length of his shadow. Nope, that's the rate at which he's moving, which is D prime. Cross multiply. 5D plus 5S is equal to 20S. Everybody okay with that? 5D is equal to 15S. Is everybody okay with that? D is equal to 3s. Is everybody okay with that? I need a derivative. Let's take the derivative with respect to time. What's the derivative with respect to time of D? D prime equals 3s prime. Do I need the current length of his shadow? Do I even need his current distance? No, I don't. So I have D prime is 4 is equal to 3s prime. But unfortunately, we don't have the right answer. How fast is the tip of the shadow moving when he is 30 feet from the pole? Tip of his shadow is moving 4/3 feet per second away from him. I want you to think about this for a second. We talked about this last year. Anybody ever been to the airport? You've been on one of those moving escalators? Oh, those are fun, right? Let's say I'm walking at 2 feet per second, and let's say the escalator is moving at 3 feet per second. Okay, and I'm walking at 2 feet per second, and I wave to you guys, and then I step on the escalator, and I'm still walking at 2 feet per second, but it's moving at 3 feet per second. How fast am I actually moving? 5 feet per second, right? So the tip of the shadow, it's moving at a certain speed away from him, but he's also moving. See, there's multiple forces that are at work here. So the question is really how fast is the tip of his shadow moving away from the light pole, from a stationary object. So we can't just use 4/3. We got to take 4/3 and add it to. I'll try to explain it right after we add this together. 12 over 3 plus 4 over 3 is equal to 16 over 3, or 5.333 feet per second. I'll try to demonstrate. I'll show you guys the problems you need to do. Let me demonstrate this in front of class so you guys can see it again.